Colorado Center for the Blind. Take charge with confidence and self-reliance.
So we're going to build rockets today, and then we're going to take them outside and we're going to launch them. You guys are broken up into teams. There's the left side and the right side. You can name your team, but we're not going to worry about that right now. What I need to happen right now is I need one awesome volunteer from each team to take a bottle from the middle of the table. You can choose your bottle.
I got it.
They're at the end, at the far end. So grab a bottle, go to the bathroom, fill your bottle halfway with water. While they're doing that, we're going to talk about what rockets need. Rockets are going to have a nose cone, and they're going to have fins. I'm going to pass around an example rocket. So as you'll notice, that rocket has 4 fins that are all about the same size, evenly spaced around it, a sharp nose cone at the top. Yes, the bottom of your bottle is actually going to be the top of your rocket. And this is because we want the water to come out of the back. We're going to be relying on Newton's laws to make these rockets go. Has anyone ever heard of Newton's laws? Yes. Can anyone tell me one of Newton's laws?
Every reaction has an equal.
Fantastic. I heard a body in motion stays in motion. What's the other part of that law?
Every reaction has an equal and opposite reaction.
That's another law, yes. But part of that first law is also that a body at rest will stay at rest unless... Exactly. I also heard that every action has an equal and opposite reaction. That's really important here too. Our rockets are going to be at rest until they're acted on by an air pump. When they're acted on by that air pump, they're going to push water out of their backsides. When they're pushing water out, the water is also pushing on the rocket. That's what makes it go. For every action, there's an equal and opposite reaction. So if I were to push on this table, it's also pushing on me, and that's why it actually takes some force to push on the table. That brings me to Newton's third law. Force is mass times acceleration. We need force to get our rockets off the ground. What happens to the force that we need, the amount of force that we need, if our rockets get more massive? Does it increase or decrease?
Increase.
Yes. Heavier rockets take more force. I'll tell you that wide fins are going to push more on the air, and they're going to be pushed on more by the air. But they're also going to make your rocket a little more massive. Wide-finned rockets so far have been able to fly a little more smoothly and stay in the air longer. The rockets so far that have had smaller fins curved a little bit. We also had some rockets where the fins were not evenly spaced around the rocket, and so they spun a little bit and they weren't flying very straight. So this is something for you guys to experiment with. As a team, look at the different shaped fins, which are all around here, and decide which fins you want to use. I will say you want your rocket to be kind of symmetric. Does everyone know what that means? Mm-hmm. Yeah, because this makes it easier for the rocket to stay balanced. In addition to fins, you're going to make nose cones. Why do we need nose cones?
Shoot through the air faster because instead of like pushing against a wide open force, it's pushing
That's
against
kind of what I meant.
Going to cut through the air, right. Excellent. Very good answers. It's kind of like why if you were to drop a flat piece of paper, it would waft through the air before reaching the ground. But if you drop a crumpled piece of paper, it'll hit the ground a lot faster. It cuts back on the air resistance.
We got some rocket names yet?
You guys want to be the A-team?
We're the A-team.
You're the A-team.
Uh-huh.
How about you guys?
I got a question. Who's Mr. T? Well, they can always be the B team.
A plus.
You guys want to be A+?
Oh.
Cool.
Wow.
So we've got the A team and we've got A+. I like it. The reason I ask because after we launch your rockets, we're going to see whose rocket goes the farthest.
So
We're going to
should
compare
the
them
fin be
to all
like
the other
that?
teams.
Like that? Okay.
Be good sports, guys. At this point, the only thing that matters is your engineering. What I'm doing right now is replacing the cap of your bottle with an adapted cork that's going to allow you to pump air into the bottle without losing too much water. Get the cork in nice and tight, and then I'm going to set it onto the launch pad so it can launch at an angle. And when I say pump, you start pumping just nice, strong pumps. It doesn't have to be fast. You just want to fill it up. When the rocket is ready to go, it will go all on its own. And you might get wet, just throwing it out there. I forgot to tell you that. You can do it. Okay. Ready? Pump. Keep going. Keep going.
Nice!
That was nice.
That one went far.
Awesome. So we're gonna leave that there, and we're gonna launch the second one now and see which one goes farther.
Wasn't it though? Like, I'll have a loose one to go from the pool bar.
Not go very far.
No, it did not.
All right, Blue Flame, would you like to, or excuse me, Nameless, would you like to try one more time? Okay, you ready?
Yep.
And go. Keep going. Keep going until it goes. Keep
Go
going.
quicker, go quicker.
Keep going. Faster. There you go. Keep going.
Oh my god! That went so far! That was awesome!
Amazing. That is the best.
Oh my god. Let's see how far this one went. Hey guys, this is how far it went.
That is easily the winning distance.
All the way over here. That's sweet.
That's impressive.
Yeah.
Are you ready?
No, it makes sense.
I was wearing those.
Wait, who's going now?
Ray.
Oh, Ray's going? Okay,
Yeah.
Ray's going down.
All right. No? Okay, pump.
Alright. Did that go further? It did! Let's see.
Right there.
I don't know. They look pretty even. It's just one curve.
I think this one still went further.
Oh, no.
Because of the angle. Let's measure it. Let's measure it.
Measuring!
All right, guys, we're gonna measure.
Alright.
Same?
Yeah, just come all the way to the end. Keep coming right there. Alright, that's firebomb.
Okay, now go to the other one.
Where's the tip of it?
Right there. Let's go all the way to the end. And then come up. Alright, and that's blue flame.
Firebomb went farther by like 5 inches.
Nice.
Oh my god, that did went farther.
Fireball.
Which one's Fireball?
To learn more about the Colorado Center for the Blind, visit our website at www.cocenter.org or call 303-778-1130.